Okay, lesson 28. The first thing we're going to talk about is this factorial notation. So it looks like 6 and then an exclamation point, but in math it's called factorial. That's what that is. 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. So all the way down to a 1. So this is 2 factorial times 4 factorial. So that's going to be 2 times 1. And this is going to be 4 times 3 times 2 times 1. So it says to evaluate this, and do not use a calculator because obviously we can just reduce. Okay, so that reduces. And then 2 goes into 6 3 times. 3 times 5 is 15. Okay? Okay, the next thing we're going to talk about is these abstract rate problems. It says a dog traveled at S feet per minute for T feet and was 10 minutes late for an open gate. How fast should the dog have traveled in order to find the gate open? Okay, so he went S feet per minute for 10 feet. So the rate for the dog was S feet per minute. The distance he went was T feet. So the distance for the dog is T feet. Okay, so if this is what he did, then what was his time? Well, rate times time is distance, right? So time is distance over rate. So the dog's time then would have been his distance divided by his rate, which is S feet per minute. And so that ends up being T over S. This flips, the feet cancel, and I get minutes. Okay. So they gave you these two and you calculated that one. Now they tell you that he was 10 minutes late. So my desired time would be what it was minus 10. Again, we know that rate times time equals distance. It says how fast should the dog have traveled in order to find the gate open? So that means we will know his rate. That's distance over time. So the rate that we want is going to be the distance. Now the distance hasn't changed, so we use the same distance divided by this rate. So we're going to have feet over minutes. So that sounds like we've done it the right way because that's a definite rate unit. Now, in order to simplify this, though, I need to multiply the top and the bottom by S because that will get rid of this fraction in the bottom. So S over S. So the rate is going to be ST. When you multiply here, you're going to get T minus 10S, and that is going to be feet per minute, feet over minutes. So this is your answer right here. So they said, how fast should he have traveled? That's his rate. Okay. And the next one says, in a test run, a truck traveled J miles per hour for K hours and was 44 miles short of its destination when a prearranged amount of time ran out. If the test were to be conducted again, how long would it take to reach the same destination if the rate of travel were increased by 8 miles per hour? Okay, so for the rate here, it says that he traveled at J miles per hour. So I'm just going to call the first rate is J, and that's miles per hour. It says he did it for K hours. So the first time that he did was K hours. So from this, I'm going to calculate distance. Again, rate times time equals distance. So my distance then is going to be rate times time. So JK, if I multiply these together, I'll get miles. Okay, so that's the distance that he traveled. It says he was 44 miles short of its destination. So really and truly, he wanted to be 44 miles farther than this JK. So this is the desired distance is going to be JK plus 44. miles. That's what he wants to do. And it says that what's going to happen when his rate is increased by 8. So his desired rate is going to be j plus 8. So it says how long would it take? So that's time. So we know rate times time equals distance. So time is distance over rate. So the time is going to be the distance, jk plus 44, over the rate, j plus 8. That's miles over miles per hour, right? Let's just make sure that that makes sense to you. If I have miles in the top and I have miles per hour in the bottom, pull this up, you can't see it, then that's the same thing as saying miles times hours over miles, multiplied by the reciprocal of the fraction in the bottom, and I get hours, and that's exactly what it should be because I'm talking about time. Okay? Okay, let's turn it over. Let's do some more. It says Kent biked F miles at G miles per hour and arrived on time. Okay, so his distance was F miles. At G miles per hour, his rate was G miles per hour. And it says that he arrived on time. Well, I can figure out the time. I know that rate times time is distance. So time is distance over rate. So his time was distance divided by rate. And that's miles divided by miles over hours. So again, it's going to be the same unit as we had last time. So this does reduce to hours. Okay, so that's his time. It says then the distance was increased 3 miles per hour. Okay, so here's the new one. In the new scenario, the distance is going to be what it was plus 3. And that's in miles. It says how fast did he have to travel, to travel the new distance in the same amount of time? So now the time's not going to change. So my time I'm going to use is the same time as this over here. Now, it says how fast did he have to ride? So I want to get rate. I know rate times time equals distance. So rate is distance divided by time. So my rate is going to be F plus 3 divided by F over G. This is miles and this is hours. Now, this makes sense because it's miles per hour and that is a rate. But I need to simplify this. So I'm going to take the top and multiply it by the reciprocal of the bottom. So it's going to be G times F plus 3 over F, and it's going to be miles per hour. You can multiply that hour. You could leave it like that. It'd be fine. Okay, let's do another one. It says a walker walked P miles to town in only Q hours. So the distance was P. Distance was P miles in only Q hours. So the time was Q hours. So what has he got? So we could get his rate. Rate times time equals distance. Rate is distance over time. Until you can just do that in your head, just write it down each time, okay? So my rate is going to be my distance over my time. It's miles per hour. That makes sense, okay? Now, it says he arrived 2 hours early. What should the walker's speed have been to have arrived on time if the town were 3 miles further away? So now, the new scenario here is with my distance being 3 more miles, so P plus 3. My time, he was 2 hours early, so the time of Q should be 2 more than that. And it says, what should his speed have been? I want to get rate. Again, rate times time equals distance. Rate equals distance over time. So the rate should be distance over time. It's miles over hours. Always make sure your units are working out right, and then you'll know when you got it in the right order. Otherwise, you may have it flipped upside down or something. Okay?